Hey, how's it going? This is Mr. Miles again. This is part of my podcast marathon. I'm stuck at school because we had the open house tonight, and so I figured might as well just stay here and do some stuff to help you guys out with getting ready for the science fair. And this one is basic steps of setting up your actual science fair project. I've been talking to some students, and I've been working with them about setting up their projects. And the thing that I've noticed, they've noticed, is that there are similarities to how they need to be set up. That's why we went over the scientific method. Now, what I'm going to show you right now is an example of a famous scientific psychological study, and how whenever you're doing a science project dealing with psychology or something like that, this is kind of how you want to set it up. So, this famous study, especially among younger people, because it's something that has made its way on YouTube quite a bit, had a bunch of people. I think it was like 16 or 20 people, all dressed in either blue shirts or red shirts, and it was somewhere around half and half. But they had them dressed in blue shirts and red shirts. And what they did was, it instructed you at the beginning of the video. It said, "I need you to count the number of people that you see in red shirts." So you're sitting there and you're looking at it, and what you start doing is you start counting the people in red shirts, and you're focusing really hard, because the thing is, they're moving all around. So you want to make sure you get the right number right, and you're just focusing really hard on that. You count it, and you're like, oh yeah, well, it's definitely 11. So then at the end of the time, I think they gave you like 20 seconds to do it. They said, "Did you notice the man in the polar bear suit?" And you go, "What? The man in the polar bear suit?" You watch the video again, and all of a sudden, you notice that in the background, behind all these dancing people, was a man in a polar bear suit. And you think to yourself, how on earth could I miss a man in a giant polar bear suit? Because it was so obvious, it was right there. And then it goes on to explain that our attention is driven so hard when we're asked to give in a problem that sometimes we just become oblivious to other things. Our brains can only process a certain amount of information at one time, so it'll actually blank out things that it doesn't think are important. And you don't actively do it. You're not aware that you're doing it, but you're doing it psychologically. So this experiment brings up a few very important key points. One was how they set up the experiment. When you guys are doing your experiment, especially if you're doing something like psychological or trying to test behavior when you're putting yours together, is make sure that the people have no idea what exactly you're doing. Now, sometimes this is a disadvantage, but really if you're trying to measure true natural behavior, you don't want them to know exactly what you're doing. Now, this doesn't mean that you just all of a sudden surprise somebody and say, okay, we're doing this and you got to follow all my directions. But try and mislead them again from what results you're trying to get. This is called having a blind study. Now, a double-blind study would be if you have no idea what results you're trying to get, and that's something I can explain a little bit more in detail in a second. But the thing is, you don't want this person to know exactly what kind of results you're looking for, because unfortunately, people have a tendency to want to please. Or if you have a mean little brother, they could also have a tendency to destroy. So they might get a preconceived notion where you can say to them like, oh, well, you won't be paying attention. You have a really hard time paying attention. So count all the people in red shirts and only focus on that. All of a sudden, they're going to start asking, wait, what is she talking about? So they're going to start ignoring what your original things are and start thinking about other things. That's not natural, because we naturally don't walk into a situation thinking that we're going to get set up. So try your best not to let them think that you're setting them up for anything. Now, when I talked about the double-blind thing, that comes into the fact of there's a famous experiment that they did a long time ago where they wanted you to check out the placebo effect. And that's saying, you have a medicine, and it's filled up with a chemical that's supposed to cure a certain disease. But at the same time, they have another medicine that's just filled with sugar. And sugar does nothing to disease. But they give it to a random group of people. So they give some people sugar pills, they give some people the actual medicine, and they monitor and they see, who's healing better. They don't tell the people, who is exactly who received what pill, and the scientists actually themselves don't even know. Now at the end, they finally get all the results. They can look at it. The people can all look at it, and they find out that actually the people who took the sugar pills were healing just the same as the people who actually took the medicine. And so that's what a double blind is, where the scientists don't know either. So just make sure when you guys are setting up your thing, you make sure that they don't know, and in some cases you want to make sure that you don't know. Now the other thing that we were talking about was variables. Now a lot of your experiments are going to deal with a lot of variables. You have variants, you have different things you're testing. Here's the thing I'm going to tell you. Test one thing at a time. So let's say you're doing one on distractions, and you want to see how good can people pay attention if they're being distracted. So you maybe use a TV, maybe use a radio playing in the background, or somebody just dancing around distracting them. Now the thing is, if you're measuring to see how bad each of these distracted versus if none of these are present, you never want to do the TV and the radio on at the same time. Because the problem you have here is if they do a lot worse than if they're by themselves not having any of these on, you have no idea if it's the TV causing it or if it's the radio causing it. I mean, you could technically do the TV and radio together to see if it makes it worse, but you always want to make sure you do the TV by itself and the radio by itself. Because then you can actually see, you can say, oh, well, radio, all of a sudden these people go from paying attention really closely. You turn on the radio and they have no idea what's going on, but the TV does nothing to them. So when you do both and you see that it stays about the same, but it's still really distracting, you know that it's the radio that's causing it, and the TV has nothing to do with it. So make sure when you're doing your variables, when you're manipulating those variables, you're only doing one at a time. Now this will call for a lot more testing, but it's really important to do. Another thing is looking at your subjects. Who or what you're testing on. Make sure that you don't use only one or two subjects, because that's not getting a very good sample population. What you want to get is you want to get as many as possible, but don't strain yourself. Don't go out looking for 500 people or 500 animals to do it on. I mean, that would be preferred, and that's what scientists do, and sometimes they go up even higher than that. But for your purposes, just try and settle on a lower number. But you want to use more than one or two, because all of a sudden, like, your brother could be the weirdest brother in the world, and your sister can also be the weirdest sister in the world. And you could get results, and you say, hey, look at this weird thing. I never thought people act like this. Well, the thing is, they don't. Your brother or sister is just extremely weird. So that's why you need to mix it up. And don't just use family members, because family members tend to have certain traits that other people do. Try and use friends, and even outside of friends, use relatives, distant relatives, or friends of friends, or your parents' friends that you don't really talk to that much. That way you get a lot more variance in the subjects that you get. So that means you get more differentiated people. So that way if you do have your little brother who's an anomaly and looks, it's just very strange, he'll actually stick out like a sore thumb, and oh, I can just throw his results out because he's just a weirdo. And so those are some basic principles that kind of go over what you should be looking for when you're setting up your experiment, and this will help you out a lot. Again, if you have any more specific questions, feel free to email me or talk to me in class, and we'll get that all set up. All right, well, thanks for watching, and I will talk to you later. Bye.